Alright, so today we're going to look at factoring. Now this should be a review for you, so we'll look at a variety of factoring techniques, and I think we'll push the frontier just a little bit farther and probably consider one new factoring technique. You might not have seen that in Algebra 1. So before we talk about factoring, I wanted to talk about one of the possible uses of factoring. Factoring is used for a variety of things, to manipulate a variety of things in algebra, so it's a very fundamental concept. What we're going to use it for in Chapter 5 is finding the zeros of parabolas and solving parabolic equations. So a zero of a parabola, what is that? A zero of any function, mind you, what is that? It's the, Richard? The x-intercept, right. So there's a lot of interchangeable vocabulary here you should be aware of. Because sometimes problems will talk about zeros of a function, whether it's a parabola or another kind of function. Sometimes they're not going to use the word zero. Sometimes they're going to use something synonymous with the word zero. So Richard said one, the x-intercept. I think that's a little bit more descriptive. When you say the word zero, though, I kind of like the word zero as well, because it's the input of a function when you toss it into your function machine that makes the output be zero. That's what a zero is. Does that kind of make sense? That's why it's called a zero. Anybody know another name for a zero or an x-intercept of a function? There's one other one which is like used old school a lot more. We don't see it as much these days, but still pretty common. It's called a root. That doesn't mean it's a square root or a cube root. A root is like the root of what you're looking for if you're digging a hole, I guess, or something like that. So I think it goes back to that kind of idea, like it's the groundwork that you're trying to obtain, the thing at the beginning. You know what I mean? So I think that the word is kind of related to that kind of concept. Anyway, so that's what a zero is. So first let's look at finding some zeros with our graphing calculator, and also finding some stuff that we looked at already, like the vertex, the axis of symmetry, any of that stuff your calculator can find, and you definitely want to be able to do that. It's pretty simple. So I thought, let's look at this first example, a pretty easy parabola. So let's stick that in y equals in our calculator. Need to clear anything out or turn a plot off, do that. So let's see, x squared minus 6x plus 8. Then I should zoom to what, you guys, to start off with? Zoom standard, okay. So here's a parabola. Remember, sometimes parabolas don't even cross the x-axis. Does this one? Yes. How many zeros does it have? 2. It clearly has 2 zeros. One right there and one right there. You could also find its y-intercept like yesterday. Let's have the calculator find its y-intercept. In our heads, though, we should know the y-intercept is what? 8, because if we plug in 0, we'll get 8. You can have your calculator plug stuff in anything you want and do it really fast. Hit second, calculate. We've done systems on this menu before. If you just hit value, it brings up an x that you can plug in. So if you want the y-intercept, plug in 0, and it says 8. If you want to plug in some other value for some reason, like 3, plug it in. It says 3. Ooh, it looks like I guessed the vertex. I didn't mean to. It looks like it's the vertex, right? How do we confirm that it's the vertex at 3? Second, calculate. Oh, and the vertex is a minimum in this case. Nice, Kirsten. So it says left bound. What do I do? Oh, you say it's like right there, so I should go a little bit to the left, right? How much you go is not real big deal. Go to the right a little bit, something like that. Guess you should put it pretty close. And it says, in fact, the vertex is 2.99999. If your calculator ever does that, that's error in its method of computing this. It uses calculus. I need 2 more years before I can explain it to you. But really, that's just 3. If it's that close to 3, it's really 3. Does that make sense to you guys? If you ever see scientific notation in either this spot or this spot, like with an e, you guys remember from last year, sometimes the calculator will output like e to the negative 13 or something. If it puts something like this in one of these spots, remember that's 0.000. How many zeros? 12 zeros. 2, 7, 1, 8. So the calculator's trying to tell you that that value is what if it says this? That's trying to tell you that value is 0. You might run into that sometimes working with the calculator as well, okay? Saying I have a little bit of an error in my calculation, but basically it's 0, okay? So if it said e to the negative 3, is it trying to tell you 0? I don't think it's ever really going to do that, but no, then it'd be telling you 0.002718. That's not 0, that's more than 0. Okay, so just a heads up, sometimes the calculator will do things like that. Okay, so we found the vertex. Let's find the zeros. So second, calculate. What do you know? It has something called zeros. There's 2 of them. Let's find this one. Left, right, enter. So one of the zeros is 2. You put 2 in, you get 0 out. I bet some of you already guessed this because you know how to factor stuff. Left, right, 4. So the zeros on this guy are 2 and 4. You can find the vertex. You can find everything we did in the last couple lessons using your calculator. It's important to be flexible and not have to rely on it unless necessary. This problem I'd never do with my calculator. It's a waste of time. I'd do it by factoring. So how do you factor this problem? There's a few factoring techniques we're going to go over. This is not what they share. This is not difference of squares. It's the most basic factoring technique where you look at the last number and combinations of it. What are combinations that produce 8? 4 and 2? 1 and 8. That's really about all the choices we have unless we go like negative, negative, right? So which combination is going to give you negative 6? 2 and 4. So you go factors, x, x, 2, 4, and then you say, okay, 2 times 4 is 8, yes. But 2 plus 4 is not negative 6. If I make them both minus, negative times negative is positive, now that still works. Negative 2 and negative 4 is negative 6. That's the factored form. And the final step in factoring to find the zeros is to say, where is the y 0? Either one of those, if either one of those is 0, it wipes out the rest, right? It makes it 0. So that says if x minus 2 is 0, the whole thing is 0. That says x equals 2 if you add 2 on both sides. If x minus 4 equals 0, you add 4 on both sides and you get your 4. That's what the calculator just told us, right? So what I just did there was show you 2 ways to obtain the zeros of a function using your calculator, which is kind of the cheap way, but very useful. We're going to use it quite often on harder problems. And using, right here I used what's called the zero product property. That's the basis behind why factoring works to obtain the zeros. It works for other things too, but it lets you solve equations that look like this. A, B, C, D. I can write as many factors as I want. I can make some of them look like weird things. But if I have an equation that has 1, 2, 3, 4, 5, or 2 factors like that one, however many factors, the zero product property says there's all kinds of ways for this to be 0. It's 0 if A is 0, right? Because then it'll be 0 times stuff. And what's 0 times stuff? 0. It'll be 0 if B is 0, because irrelevant what this stuff is. That's negligible. If this thing's 0, it's going to chop all that other stuff off and make it 0. This is the property that, like, the Mayans originally investigated with when they figured out what 0 was and why it was special. So, likewise, if C was 0, the whole thing would be 0. If that's 0, the whole thing is 0. If this weird E minus smiley face thing is 0, the whole thing is 0. That's the zero product property that I just used to split it up here. Okay? So this is all review. You guys are feeling pretty comfortable with this, are we not? Okay, good deal. So let's factor some more problems and we'll leave off for today. Oh, should we look at the calculator one more time on something kind of random and see where the calculator is nice to have? I think we should. Let's look at one more example. Me making stuff up. 3.2x squared minus, let's go plus 4x minus 7. I bet that one doesn't factor, because factoring doesn't work in all cases. It's just one approach. parabola I picked, what's the problem with it? It doesn't have any zeros. It has a maximum. I want to get one that has zeros. So let's go change my parabola. Instead of -7, should we just go +7? I could have made the parabola positive. You're right, Richard. Let's go with Richard. We'll go with what Richard said. I like his suggestion. Yeah, there we go. Now we've got one with some zeros. Let's calculate them. Second, calculate. So if you're one of those people like on that last test who's like, I'm just going to press trace, and it's somewhere in here. I'm going to say 0.9. This is not really good enough. You want to go second, calculate 0, and have the little like gnome inside your calculator do some calculus and get it. So left, right. Now it's inside my gnome's net. And that's what it is. So when you guys estimate a 0 like this for me, I'd like you, regardless of what the book ever says, to try to go and say 0.981. Round at the thousands place. Why? Because that's what AP exams like you do all the time. So, good habit to have for those who are going to continue. Let's get the other one. Second, calculate 0. Now I'm going to go on this side. And I'm going to go on the left. That's on the left. On the right. And about right there. So the other one for this guy is -2.331. You guys understand my rounding there, right? That's more than 5 or more, so kicked it up, okay? All right, let's look at factoring a few more questions. Let me see, I had some in mind. So I was going to say, let's do this one. Let's do this one. Because there's more than one factoring technique. Let's do this one. Okay, do I have to use a different technique on number 1 or not? No. I can still look at this last number, and if it factors, some combination should add up to the middle. So what are we looking at combinations of?
2 and 6.
2 and 6. Don't be trying to put negatives in here. You know, I was taught that way, and it always confused me, and it made me waste time. Just think about positive numbers here. 2 and 6 give you 12, right? 3 times 4 give you 12. 12 times 1. You don't have to list them out exhaustively. Wait till you think you've got the right one. Which one of these might somehow give you 4 when you like add or subtract them? It's 2 and 6, right? But it's not just plain 2 and plain 6. One of those has got to be negative to give me this -4. The 6 does. So that's where you put the negative in. Don't worry about the negative until the end. Otherwise you're wasting time, I think. So we're going to say we're trying to get to zeros, so y is 0. Factors are 2 and -6, x minus plus. It's factored. If you want to check real fast, that times that's that, yes. 2 minus 6 is -4, yes. It's done. And now I use the zero product property, so I say, okay, that really says where is that 0, or where is that 0? So really, there's actually an or symbol in here the whole time. Not an and, right? Because and is not going to work in this case. So this one's going to be what, guys? -2. Yep. And this one's going to be 6. So there you go. There's 2 answers on that. Which other one of these is going to work the same way? If it works with factoring. 4. 4 has 3 terms. If it factors, it will work the same way. So let's try it. 0. What should my next step be? Descending order. Thank you, Mary. Very nice. Turn it around. What should my next step be? Yeah, not yet. You can only do that if this coefficient is positive 1 exactly. Otherwise, you have to use other techniques, which we're going to go over tomorrow. So, can you make this turn into positive 1? It's an equation. So do something to both sides. Yeah, divide or multiply by negative 1, it'll work. Multiply this side or divide, do the same thing to this side. 0 isn't going to be affected by anything, right? But now I can go x squared minus x minus 30. That's just the Old Testament rule right there. And now let's see. Factors of 30, what do you guys think? 5 and 6 is going to work. You can play around to 3 and 10, 2 and 15, all those things all day. 5 and 6 is the one, though. So that's going to give you 1. Which thing's negative? 6. So you're going to get x minus 6, x plus 5. That times that is negative 30. 5 minus 6 is negative 1. So there you go. So this one is going to give you 6. This one's going to give you negative 5. So I didn't show as much work on that one. That's fine. Just make sure that if you need to, you can write out this zero product property thing, because some problems will be harder than this. So, okay, that's all there is to it. Now these ones I think need a couple other techniques. So far, I don't have a good name for what we did. I call it standard trinomial factoring. There's not a great catchy name. You can't do that on 2 or 3 here though. Who can remember what to do on number 2? Cameron?
Can we do difference of squares?
Ah, that's one of them. Is this number 2 difference of squares though? Is 18 like a nice square number?
No.
Is this a difference? No, it's a sum. But yes, you remembered one of the other ones. Can you use difference of squares on this one? Let's find out. This one doesn't even have a function name. It just says solve, so I think you want to do this first. Subtract 25 on both sides. Now, is that a difference of squares? Yes. So that one you do use difference of squares, like Cameron said. What's being squared here? Difference of squares always goes minus plus in whatever order you like. What's being squared here? Careful.
X.
I hear 2, I hear x.
2x.
Ah, 2 and x. Are both being squared there, right? Factor. Done deal. So we've got 2x minus 5 equals 0 as one. And we've got 2x plus 5 equals 0 as the other. Those are both two-step equations, so you get 2x equals 5. That's 5 halves, or 2.5. And the other one, by symmetry, will be negative 5 halves. Or you can do it the longer way. Okay? So that one you can't do difference of squares. So far, remember, standard trinomial, difference of squares. What's the other big one, the other big, basic, easy one?
It's an elimination process.
Remember, we're trying to get like multiplication. The whole essence of factoring is turn stuff with pluses and minuses in it into a product. Turn stuff with pluses and minuses in it into a product. That's why it's so versatile besides just solving parabola junk. Okay? So how do I turn this plus into a product? Kyle? You have an idea? Bradley?
3x and 6x.
I like what he's thinking. 3x and 6. He's seeing like a 3x. I think he's seeing what they have in common. That's the other technique. What do they have in common? What do they share? What do those two terms share? Bradley identified it, 3x. What's left when you pull it out of each one? That's what he didn't do. Good. What's left when you pull 3x out of 3x squared? 1 more x. What's left when you pull 3x out of 18x? The x has been pulled out. So 6. There's Bradley's 6. And what goes in the middle on this one? Plus, right? If you're not sure, distribute it back through. That's what you can always do with factoring. That is 3x squared. That is 18x. That is the same thing. The whole reason we did it is so we could take advantage of the zero product property, which says either that is 0 or that is 0. Divide by 3 here. I'm going to go a different color. And you get x is nothing. That's an answer. And here you get -6. So far, to recap for today, factoring techniques we've learned are what? Difference of squares. You should be able to say these. What they share, and whatever you call that other one, right? Standard trinomial, whatever. Okay? I call it a standard trinomial because it's got a equals to 1. When a is something else, you got to do something else. We'll look at that tomorrow. I'll see you next time.